What's up? What's up? Welcome back. Today we are working on writing a QR code decoder from scratch. We're on day 3, and what we have right now is we have the ability to take in one particular image. We haven't really tested on any others. We have this one QR code, and let's see, if we kind of look at kind of like the size of the image, the QR code has like some space around it. So we found the locator patterns, which are, or finder patterns, I think they call them, which are these like 3 corners. We found them by kind of walking in one dimension, looking for a pattern of like 1 by 1 by 3 by 1 by 1. We find a bunch of candidates in each dimension. We see where those two guys intersect. Boom. We like average out the points. There's like a little bit of error we have to do there, so we find like some candidate points, bucket them, and from there we can like find the ROI, we're going to call it region of interest of the finder pattern. So we have these yellow boxes that we've drawn around indicating that we found them correctly. From there we can kind of guess the size of the total QR code. So we just take like the borders of our finder patterns and we draw a QR code, we draw a box around that. And then we went from there and we found, like, we read one of the timing patterns. So these timing patterns are on this row and this column. They're alternating white and black, and we just like proved to ourselves that we can iterate those. We found the size of the boxes, and then we've iterated them. So we've got like all the pieces there in order to start like extracting data from the QR code from wherever we want it. And so today's plan, like every day's plan so far, has been to try to extract data from the QR code. On day 1, we were like, we don't know how long it's going to take. Day 2, we also didn't know how long it's going to take. Day 3, maybe we'll get there. Maybe we won't. Who will see. And if I understand this correctly, there is kind of like an area, maybe like here. It's here and here, I think, and here. There's like formatting info that tells us some important pieces of information about the QR code. Specifically, it's like masking pattern. So depending on the format, these like first, or is it these bytes here? It's either, yeah, green. Green is mask pattern. So depending on like these 3 bits or these 3 bits, whichever ones we decide to read, we have to apply some pattern to the entire QR code. And you can kind of like rationalize this pretty easily by looking at a QR code and saying like, well, there's kind of like an expectation that there's some amount of like blockiness to it, right? And say we were to write a QR code where every single value in the code was 0, we would get like just one blob of color, and that wouldn't be very useful. So what they do is they apply these masks, and basically like, I think it's black is XORed with your input, black or white, one of the two. Just like flip bits essentially. And so then you can end up in the situation where you always at least have something interesting, and something like semi-high frequency. So plan is try to decode the mask pattern. Once we have one mask, we only have to implement one of them. Then we can set up like an iterator that will walk the entire grid. There's like a special walking pattern where you have to go like zigzag and follow this pattern like this. I don't really know the rules about like what happens when we hit the finder pattern. How do we know when to turn and stuff? I don't understand that yet, but hopefully we'll figure it out. And then once we've like walked the data, we can like apply the mask as we're walking, and then hopefully we'll have like some data. The data is encoded via some rules, right? So they have like several types of data that it might be representing. And so like, I think the idea there is like, if you say, hey, we're alphanumeric, we only have to have 44 different possibilities, and that probably simplifies like error correction and like data per error correction bit or something. Not really sure about that, but that's my intuition there. And yeah, that's the plan. So I think let's just get moving. So we are 4:15 into stream, and we are looking at decoding the format info. Okay, so things have changed a little bit off stream since last time. I've pulled out this QR code abstraction. Let's see, where is he? Const QR code is equal to struct. And he stores like the region of interest in the image of the QR code, as well as the size of each block. And then what I added was this like iterator that we can run that will like walk the timing section. So like he's gonna start here and go boom, 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 and then stop. And so I think that probably I'm going to do the same thing for formatting info. So let's look at this picture again, and we can make a little guy that pulls out format info. So what I don't really understand here is we have some error correction stuff. Oh, I think it's I think I get it. Okay, so you can either read, I guess there's a horizontal and a vertical version, right? There's the horizontal version that goes boom, 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 and then extends over here. And the vertical version, which walks like the right side of these. So maybe for now, we will just pull out the horizontal one. I don't really care about, we're going to assume for now that there's no like corruption. Because I don't want to deal with that yet. It sounds complicated. I've been like looking at the math there a little bit, and it's not trivial. I've been kind of like building up an understanding, but yeah, it's not simple. So we're not going to worry about like reading like the error correction bits. We're not going to worry about like consistency between horizontal and vertical. We'll just assume that what we have is perfect for now. So maybe here we'll get like a horiz format iter. And this guy is going to return a horiz format iter, and we're going to have to make this a thing. So what is he going to do? He's going to store his X position. I think that makes sense. He's going to store a reference to the parent QR code. I think that makes sense. And probably we just need to create like initializer and next function. Boom. And the next function returning a rectangle seems pretty reasonable. So we can kind of like say that each step of this iteration is going to return a box that represents the pixel that, or the like QR code, I don't know what to call it, block that we care about. And then if like that allows us to do things like draw a box around it if we want to. And then later we could do something like extract whether it's dark or light via some rules. I'm kind of thinking that it makes sense to do it this way because you can imagine a world where in the future we might have a QR code that doesn't like perfectly align with the grid itself, right? So you might have like a QR code that your camera found that's kind of like, I don't know, like on an angle like this. And you might want to like walk the finder, the format info this way. And your concept of whether or not the thing is going to be dark or light is going to be much more complicated, right? You're probably going to run some sort of like image processing on like a region of interest. Here, you might want to say like, oh, do I expect like this type of edge to show up in there, like whatever, right? So I'm thinking that by making an iterator that returns region of interests, that's not really like harder now, and will kind of make that an easier transition later. That's the reason I'm doing it this way. Also, it makes it easier to do things like draw the boxes in our visualizer right now without like injecting the visualizer into the QR code. It's just, yeah, there's iterators feel nice is essentially it. Okay, so our X position is going to start at 0.0. Our positions have like sub-pixel accuracy because we are drawing with like SVGs on an image that's actually quite a bit smaller. Like this is a 100 by 100 image. But these boxes, let's see if we can actually take a look at them. Right, like our center of our thing is like at 16.5, and we have like widths and heights that are maybe not perfect pixel widths and heights. Why are all of these things circles? Where are my boxes? Oh, show all 217. Actually, our widths and heights are all 4 and 4, so that's fine. But there could be a world where they're not. The position is representing the top left corner, so top on Y, left on X. And so our iterator is probably just going to walk the first certain amount of bytes, or I shouldn't say bytes, bits / positions. So that's 1, 2, 3, 4, 5, 6, 7. And I guess it like depends on like the size of the finder. It's just basically going to stay under the finder. So probably what we should do is, I haven't pulled this out yet, but I think it's useful, is we're going to have like some concept that's like finder num elements. And this is just going to be a usize, I guess. And it's going to be 1, 2, 3, 4, 5, 6, 7. And then we can use that to say, itself is equal to this. We can use that to say, we want to walk from the left edge to until we hit the number of finder elements. So while I guess we have like kind of like two stages of our iteration, right? We have kind of like left half and right half. And I guess in each iteration, we're going to move one element width to the right. So we're just going to say x pos plus equals self QR code dot lm width. But then we just have to handle this one condition where if we are at here, then we need to jump over to this position. So this is going to be like if x pos is greater than finder num elements and x pos is less than finder num elements from the right edge. So this is going to be like self QR code. Do we have like a width of this guy? We have an ROI. So we can do something like we have the self QR code ROI right. This is the right edge of the picture. Minus finder num elements times the element width. Yeah. This is the what do we want to call this? Second half start. And I guess technically it might make more sense to store this as a member so that we only have to calculate it on one time. I think that makes sense. Because then we can just calculate this up here, and every iteration we're not calculating it again. Second half start is equal to this. Womp, womp, womp. Okay. And now we can just say if x pos is greater than finder num elements. I guess we can say first half end. We should store this as well. So self.qrcode.roi.left plus finder num elements times the width of the element. I think that makes sense to me. And this shouldn't be 0. This starts at the left edge of the QR code. Yep. So if our x position is greater than the first half end, let's think about this. Plus finder num elements. So this is here. Then we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So this plus 1, 2, 3, 4, 5, 6, 7. Okay. Yeah. So it's going to end up right here on the right edge here. So here we're saying if we're greater than that or equal to, and I guess we should probably add some sort of like error margin here, right? Like just because we're doing like floating point comparison, it's kind of like nicer if we were to subtract here the, do we subtract here? Maybe we say that this is the first half end, and then we on our comparison we subtract lm width over 2. That feels like logically like it makes more sense to me. So if it's less than this, or if it's greater than that, and it's less than the second half start minus lm width over 2.0, then we do something. Lm width is not defined, so this has to be self dot, and this is a nasty condition, so we'll factor that out later. So here we're going to say that in this case, the x position just jumps to the second half start. Boom. Okay. We need to set first half end as an F32. And remove some selfs from here. Okay. Now, on each iteration, we actually have to do something. So var ret is equal to some rectangle. So it's just going to be a rect where it's going to be a rect. Am I right? Return ret. Each element. So we're going to have like the left is going to be our x position. The right is going to be the x position plus the element width. The top is going to be I guess we need to store that somewhere. I guess it's kind of known. It's this is a constant. The top is always going to be the finder num elements times self elem height. Like this. HEIGHT. I guess this is going to depend on the element height though, so we can store this as well. Fuck it. Top is a F32. And we'll store this here. Okay. Okay. And I guess we will compute the bottom every time. Fuck it, doesn't really matter. Self.top plus self QR code.lm height. Yeah. Then we return ret, we increment x, and now we just have to cover the last case, which is if we are out of the ROI. I guess we'll do this here. Is greater than or equal to what? Self QR code dot ROI dot right minus self elem width over 2. Then we return null. I think that makes sense. So here we're giving like half a block's error margin because floating point. Otherwise we're chilling. And I guess we'll just kind of see what this does. So if we go to main, and in here we say, hey, could we get a format iter? Horiz format like this. We can basically just say, hey, while we get a value out of this thing, can we like draw a box? Let's just draw a box and just see if it kind of did the right thing. Okay, so we run, we build. He's mad because I fucking typoed here. We build, we run. Is const the same as const in Rust? Const in Rust, I think, is compile time constant. I think const in this language is more like C, C++, where it means that it's like a non-mutable thing. It's like the same as dropping mute in Rust, I think. But I think that the compiler might be smart enough to understand when something is a compile time constant or runtime constant. I haven't really like looked into that too much, but I know that there's a lot of stuff that can be done at compile time. I don't know how smart it is about actually doing stuff at compile time. Okay, what's it complaining about? What's it complaining about? So here, expected type horiz format iter found timing iter. Oh, because oh yeah, this is format. This is format. This says timing, so this should say format here. No field name elem width. So let's look for that. So this should comes from the QR code that is being referenced. Okay. Otherwise it builds, and we can actually refresh here. And we're close. In that, like, the X positions were correct. The Y positions are totally fucking wrong. Because we forgot to add in the top of the QR code's region of interest. So we can say QR code dot ROI top plus this. And then it's actually plus 2, because 1 plus this thing is like a spacer, so we need to go finder num elements plus 1 times this. Okay, let's try that. Boom. Okay, there we go. So we have successfully walked the format iterator, or sorry, the format info, we like have those boxes, and now all you have to do is like extract the masking info. So what was that again? Masking info was bytes or bits 0, 1, 2, 3, 4. 2 to 4. So maybe, how do we want to do this? How do I want to do this? For now, I'm just going to do it in main because I don't really want to think about it. Later, I'm going to move this somewhere that makes more sense, probably as a member of the QR code. But we're going to say, give me an index. Oh, this is not how this works. Var I equals 0. And then we will say, if I is... I wonder if there's like an in-range function. Zig standard library. It's easy to write one, but if there's one that exists already, contains range between. Yeah, I don't really see anything that's obviously what I want. So for now, we just function between. We take in a, which is anything, a B, which is the same type as A, and we return a Boolean. And we just say, and we want the value as well. So I guess this is type of val on both of these. Okay. Now we can just say return A, or val is greater than or equal to A, and val is less than or equal to B. Great. And this needs to be and like this. Okay. So if I is between, what was it? 0, 1, 2, 3, 4, 5. 2 and 5. Which I guess means that this between, this less than or equal to at the end should be less than. How does Zig know it's a comparable type? Well, it doesn't really. It's like kind of like C++ templates, where you kind of like shove the type in, and then Zig finds out, because it's like lazily compiling it. So I think what ends up happening is it like makes a new version of the function for every set of types that you can put in. So we'll see. Didn't realize you compare the size and floats. Wonder if that works because float num elements is comp times const. Oh yeah, that's a really good point. I expected to have to float cast that. That is surprising to me. But yeah, I would. Yeah, maybe the compile time constant is making a difference there. That seems reasonable to me. Okay, so if I'm between 2 and 5, then what? Then I want to say that the mask value is going to be adjusted by this. So we're going to say what? Like mask val or equals. We're going to have to extract the value. So we're going to say is light ROI. I think this comes from QR is image is light ROI. Yes, okay. So we take in our ROI and we say if this is bright, we are going to do something. This takes in the image as well. Okay. So I guess this can be folded in. So we're going to say if this is like this and it's a light thing, we are going to or into the mask. So we're going to say I minus 2 is going to make it 0 for the first time that it fits here. And then we're going to say mask val or equals 1 shifted left by this amount. And we're going to have to int cast this because Zig wants my shifts to be, how do I say this? It wants to make sure that, like, at compile time, it wants to know that the shift is going to produce a valid type, right? So if you have, like, an 8-bit value, you can't shift by more than 8. So you shouldn't be, your type should be a U3, and then, like, this has to intcast to say, if it's not a U3 at compile time, then, like, we need to, like, do some runtime checks to make sure that it's a valid thing to shift by. Mask val can stay as U8. Use of undeclared variable max val because it's mask val. And then here we should just be able to say print found mask value like this. Type of val A would do pure type correction, by the way. What does that mean? Okay, type of, let's look at this. Zig language docs. So you're saying I can feed in multiple things to type of. Number expressions parameters to the type of the result using peer type resolution. Okay, so what is this? Peer type resolution occurs in these places. Choose a type that all peer types can coerce to. Ah. Okay, so when would I want to do that? So here I would want to like pass in, presumably, it's something like here I want all three of these guys. I don't really care if they're like the same type. I just care that they're comparable with each other. And so like you could maybe somehow use this type of thing to try to make it so that all of these guys get coerced into the same comparable thing. Not really sure. Not really sure. It seems like both of them being type of val seems reasonable here. Okay. And this is stood debug right here. And we can see, maybe we print this in binary. Because that'll make it clear if it's right or wrong when we look at it. I needs to be set here as a type something. And we also have to increment it every time we do this. So I plus equals 1. So let's start this as just like a usize, I guess. It's useful when you need to common type with several any types coerced to. Oh, if you're like returning type of AB, I could see that. Okay, so here expected a pointer type at 177, so that's here. Expected a pointer type is here as well. All right. Unable to cast runtime value to comp time int because this guy needs to say that, hey, I am expecting to be, I guess I could say type of mask val is like technically what I want. Even though I could just write U8 here. That means if I decide to change it, it'll be simpler. Expected, oh, I got this backwards. Like this. 1 here. Okay, found mask value, 0. Is that correct? Yes. It's these 3 dark patterns here. 1, 2, 3. So that means that we are in this mask pattern. I think there's this like weird shit going on where there's this like XOR value that you're supposed to provide, but I think here they said that note that we map mask values directly to its meaning here in contrast to image 4 levels in mask, where the mask pattern numbers are the result of putting the third and fifth mask bit over the third. Yeah. So there's also this like XOR shit you're supposed to do on these format rows, but in this mapping they're ignoring. They're saying like we're kind of like baking it into the mapping. Okay, so we have this. Mask pattern is j% 3 equals 0. So I guess it makes sense to maybe make a mask pattern enum somewhere. Because right now we have this one particular one, but we're eventually going to have more than one. So we can do something like const mask pattern is going to be an enum, I guess. I think that makes sense. And he is just going to be, like, we have to name them? Maybe? Do these have names? If they don't have names, we could maybe make them up, which would be kind of funny. I guess we can just store it as a 3-bit int. I guess that's fine. It would be more fun to name them, but 3-bit int is totally reasonable. So here, our mask value should be U3. And that's where this type of stuff kind of line makes everything work out. Okay, mask value 0. And then I guess here we're just going to say, what do we want to do here? So we're going to want to like apply the mask as we're iterating, which means that we're going to have to know which function to call, which kind of means that like, I guess probably we're going to have some sort of like function pointer that takes in X and Y position and returns stripey. Right, like, how do we go back? Where was I? Wikipedia, back, up. Right, like here, we're basically just going to take in X and Y and return true or false for if this thing's maybe a U1, not really sure. Yeah, that's reasonable. Okay, so let's say pub function mask is mask pattern 0. I think that's fine because we don't really have names for them right now, so just saying mask pattern 0 seems reasonable. And this is going to take in an X and a Y and return a bool. And this is just going to be return X%3 is equal to 0. Right, this is vertical, so we're using X position here. And here we're just going to discard Y like this. Okay. Then we can do something like var mask function is equal to switch on a mask val. And if we see the number 0, we return QR mask pattern 0 as a function pointer, I guess. Else we log an error. And we say unimplemented mask function. Error unimplemented. Okay. Which means that now we can start doing something like trying to set up a grid iterator. I think we can just start walking this thing and applying the mask and see what fucking happens. Okay, so we are at 33 minutes in the recording, and we are on setting up a grid iterator. Okay. So from here, it looks like the rules are: we start in the very bottom right. We follow this bit order, so we go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then here, we start going, like, there's some rule we have to follow for if we hit the edge. So here, it looks like we keep zigzagging in the order that we were before. These 1, 2, 3, 4s here, so it's 1, 2, 3, 4. Then we detect that this is like an invalid area, and then we just go left, 5, 6, 7, 8. And then we keep iterating this way, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Yep, it does follow the same rules, and then we just keep going to the left, 5, 6, 7, 8. Okay. Sure, makes sense. Makes sense. So let's make some sort of grid iterator. So what's he going to be? He's going to say, I am a grid iter, or data iter, maybe we call it. Seems reasonable. He takes in the QR code, and I don't really know. He's probably going to store his like X position as a float and his Y position as a float. And I guess, like, how do we know which way we're iterating? right? So the first thing we're going to do is move left. Then we're going to move up to the right. Left, up to the right. Left, up to the right. And then when we're walking down, we're going to move left, down to the right. Left, down to the right. I suspect that the only pieces of information we need are a Boolean for if we're going left or vertically. So the next move is vertical. Or, yeah, okay, so 1, 2, false, or true, false, true, false, true, false, true, false, true, false, true, blah, 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 true, false. Or here it's going to try to move up, and then it's going to give up. And so we're also going to have to store these like regions where the like blackout regions, we can call them, or something, where we don't try to iterate. Yeah, okay. So we'll try that. We'll try that for now. So we'll store our positions, X and Y, as well as next move vertical. And we're going to have some sort of initializer function that takes probably in the QR code as a const QR code and returns a data or self, I guess. Okay. And then we're going to have some next function, which is going to return, it's going to take in self by pointer, sorry, no references in this language, and it's going to return a optional rectangle. Okay. And we're probably going to have some sort of functions like is valid, and we're going to take in a rectangle probably, like this, and we're going to return a Boolean, and we'll stub this out for now, but I'm pretty sure this is going to be important. And then here we're going to say we have our X position, we have our Y position, and we're going to say next X is equal to, okay, so we're going to look at our self. We're going to say, is the next move vertical or not? Yep. No matter what, we're going to flip it. So equals not self next move vertical. Yeah, I think that's right. Then here we're going to say if it's vertical, our X pause is going to increment by the QR code LM width, right? Because here we're going to go, if we're like starting in this bottom right corner, we're going to move left 1, and then for vertical, we're going to go right 1. Left, right, left, right. And I think that that's true the whole way. I think every time we're moving vertical, 2 to 3, 6 to 7, 6 to 7, we move to the right. So here we're going to move our self X pause over to the right. And our Y pause is going to depend on the direction. So should we be deriving our direction in some way? I guess we'll just say vertical direction, and we'll just say true means up or something. I guess we should just name the thing so that we don't have to comment that. Moving up. Okay. So here we are going to say that the Y position var vert movement is equal to, if moving up, it's going to be the negative self QR code LM height, else self QR code dot LM height. And I guess maybe this feels nicer if we say this is the self QR code LM height, and then we can say if moving up, then we just adjust it. Vert movement times equals -1 or something. Okay, so this should be not moving up because up is negative. Yeah. Okay. Otherwise, it's just the self x pause minus equals self lm QR code lm width. We just move to the left unconditionally. Okay. Okay. What happens now? So that kind of covers blah 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 blah. But at some point, we're going to hit an invalid section, and it looks like from this, the invalid sections are always going to be hit vertically. No, this is sketchy down here. Here we're going to like smack into the bottom edge, move left, and then we're gonna like be like kind of go all the way up to here. So how do we detect that? How do we detect that? My gut says that we're gonna have this is like 3 state, like our direction. Okay, so we have like moving up, then we're moving sideways, then we're moving down, then we're moving sideways. And this case here is, I think, the only... let me think about this. Here, it's obvious to me. We hit the top, and then we just move left. So here we can just say, if it's not valid, I guess we will we will make our rectangle var rect is equal to some rectangle. So here we have left is equal to x pause. Right is the x pause plus the lm width. The top is the y position. And the bottom is the y position plus the lm height. Now we're going to do something like this is going to have to be like in a loop, I think. And I guess here we're going to adjust the movement first, then create our rectangle, then check if the rectangle is valid. Yes, that looks right. So we're going to say if is valid rect. If this is not valid, then we have to turn. So here we're going to say it's not valid, and for now, do we just assume that it's a vertical move? I think we do. This is going to break later, but that's okay. Or I guess maybe we just continue here. Otherwise, we return rect. Let's think about that. So that means that we're going to go we're going to hit this, and I guess we actually do we have to do some adjustment here. And go again. So I guess we'll say like if next move vertical, then we undo the vertical move. And maybe we do this. Old y pause equals self.y pause. Old x pause equals self.x pause. We reset. Self y pause equal to old y pause. And self x pause equal to old x pause. and then we move left instead. Else, so the other condition is that we're here, we move left and we run this guy. And here we just kind of want to follow the pattern until we get back into valid area. I wonder if that concept works here too. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I don't think that this lines up on the grid correctly for us to just kind of keep walking. I don't think. Actually, I don't really know if it does here either. So here it's like if the left move was bad, we kind of have to like shoot up. So just keep moving vertically until we spot. And we also have to handle the move direction here. So here we go left and we turn around. We have to turn around. So self-moving up is equal to not self-moving up. And for now, I think I'll just stood debug panic here and say ruh-roh. No, we'll just return null here. And log an error. Do not know how to handle horizontal out of bounds. There we go. And I think you have to put one of these guys in here. And then what should happen is when we call this loop, we'll just stop iterating at that point, but we'll be able to like write out our like debug visualization to the point where we can like inspect it. Okay, so what's our like end condition? I guess this is our only end condition, which is fine. That's fine for now. Now our is valid. He needs to basically check if we're in format info or finder region. So we can just look at the top and the left. Okay. And we basically just want to say like, if x is less than the QR code.lm width times finder num elements plus 2. Yep. We'll say that this is const x in finder region is equal to this. This needs to take in self. Yep. And then there's this other case, or very similar condition, but it's going to be something else. This is careful. We have to be careful here too, because we have to be relative to the left corner. Yep. And this is going to be self QR code ROI right minus these things. Yeah. Yeah. And then we have the same thing for Y. But this is going to be top. And this is going to be LM height. And this is going to be bottom and LM height. Okay. And then we can say if X in Finder region and Y in Finder region, this is not supposed to be double ampersand, this is and. Then we just return false, otherwise return true. All right. I don't know how right this is, but we will find out. And then we just initialize, so return something. We return the QR code is equal to QR code. X and Y both start as top. Yeah, it's a good point. Good point. Good eye. Okay. QR code is QR code. X pause is equal to QR code dot ROI dot left. No. Right. And the Y pause is the bottom. But I think that we're doing pre-movement here, which means that we actually have to start one past, which actually is kind of happening for free here because the right and the bottom are like the bottom right corner here. They're like here. And so we will immediately move either one to the left or one up. So one of these has to be minus self ROI or QR code ROI LM height. Okay. So the first movement, that means that we want the first movement to be horizontal. I guess we kind of want to start it down here so that it does a diagonal move up immediately. So this is minus 2 times QR code LM width. And this stays at bottom. I think that's right. So then the next move vertical starts as true, and moving up also starts as true. And who fucking knows how broken this is? This is likely very broken. But we can just start using it and find out. So we make a function that returns a data iter, and we just say return data iter dot init self. And then in main, we can say data iter. Yeah, we'll say data iter is equal to QR code data. Yeah. And we'll say, well, data IT next. We get the ROI. I guess we will just draw a box around it and make it orange. We're running out of colors. Mask function is not used. We'll have to fix that later. But for now, we just want to get... Let's just see if we're getting the order of operations correct. Okay, he was complaining about something at line 396 here. This is supposed to say self.isValid. Okay, he's iterating forever, which is a problem. So I wonder maybe what we'll do for now is std debug print. So we have x is something and y is something. Maybe we'll say position is number comma number. Yeah, and we'll print out x and y. And this will give us some clue. Okay, so the y position is just incrementing forever. Clear bug there. And so why is that happening? Shouldn't... Oh, because we are probably a y in finder region. So clearly we might... Well, maybe we hit the finder region and we just don't turn around properly. So let's maybe breakpoint in this is valid section. So break here, run. Okay. So we have 8896 is not valid immediately. I see. Because with our y in finder region and x in finder region. Okay, hold on. Something about this doesn't feel right. Because this is the first iteration. So what's happening here? B is valid. No. B self. B. Let's just fucking find the line and column. So we'll just yank this, GDB, break here, run. And can we just like print X in Finder region, Y in Finder region? Right. I mean, I guess that kind of makes sense because we have like X is anything on the left of here, and Y is anything above or below here, and it's just like this corner is the same as that. So I guess the X in Finder region depends on Y being less than something as well. Okay. So this should be like, and Y is less than. Okay. We need to make our little variables here. Const X Finder. Const Y Finder end. Ugh. Const Y Finder height. Yeah. Is equal to this. This is actually Finder width. Finder width. Then Finder height is lm height. Okay. Now we say X in Finder region, we limit this by something. So we say X is less than the left plus Finder width. This is fine because this is the left edge. That's always going to be fine. And then here we just want to say on the right side, or X is greater than the right minus the Finder width, and X is, and Y is less than QR code ROI height plus Finder height. What a shit show. But I think that's right. And then we do the same treatment for X, for Y, but it's based off of Y is less than the top and the height, or it's greater than the bottom minus the height, and X is less than the top. X is less than the left plus the Finder width. And this should be top. Will the number of steps be the same for any QR code? It looks like some kind of lookup table might be nice. I think no. I think for the different sizes it will change, but I'm not positive about that. I'm not positive. Zig, build, and run it. Okay, so here we are still just fucking running it. So can we look at PX in Finder region, PY in Finder region? Okay, so they're both false. That's great. So can we finish this function? So we said it's valid. Continue. Okay, maybe we can like limit the iteration so that we can actually like see what's going on. So we'll say I equals 0 here, and we'll say I plus equals 1. And we'll just limit if I is greater than or equal to like 20, return. And then we can build and run it. Okay. So here we're going the wrong way. Which seems kind of like a bug. Seems kind of like a bug. So moving up. Maybe we'll also print that we're not valid. Stood debug log not valid. Stood debug print. Let's just see. So here we have all valid positions, but we are moving down instead of up. So that just means that here, this is backwards. But why? GDB break here, run p self QR code lm height 4. Yeah, okay, so if we are not moving up, that condition's backwards. It's if we are moving up. Okay, let's try this again. Okay, let's maybe draw out. Oh, we do draw. Okay, so can we just do? Okay, wait, that's promising. That's promising. We do see this. It would be kind of nice to get some indication of like the order that we iterated in. I wonder if we can like draw the index inside the box. That'd be kind of cool. I wonder if that's possible. Let's add something like pub function draw text. And we are going to take in some like X position and Y position and some text. And I guess that's going to result, like main, we're going to create a text node in our SVG. And eventually we're going to finish the node. And we're probably going to add an attribute of its X and Y position. I'm just kind of making this up. I don't actually know how this works. And then I think the text goes inside. We could just like inject something here. Can we just like edit as SVG? Can I just like text hello text? Like what happens if I do that? I guess I could actually edit the SVG on my disk. That probably makes more sense. So here if I do like text and say like hello with like X equals 10 and Y equals 10 or something. Is that how this works? Oh god, reset. I put a comma in here when I shouldn't have. And here. Text SVG. We can just see. So class small, heavy, okay. So that feels like it was right. What's the problem? What's the problem? Oh, it's here somewhere. Maybe. Oh, it's because I drew it before the image, and so the image gets painted on top. There we go. Nice. Nice. Can we make it red? Or something? Nice. And then fill also red. Yeah, okay, that's not too bad. And then can I set like the size? Let's see. Text length X, Y. Size. No, I guess I have to specify a font style. Gross. Oh, I see. So this class is doing nothing. Probably. Yeah, okay. SVG shrink font or font size. Oh, here. Oh, here. Font size equals something. So here, if I write font size here equals 4, what does that do? That makes it really fucking small. Okay. It looks like fucking shit. Can I make like, what if I make the font size even smaller? I guess like the thickness, I probably have to change the stroke width is equal to 0.1 or something. Oh yeah, there we go. That's legible. Okay. We're copying this. And we are going to our draw text, and we're just gonna slap this here for reference. So we have a text, X and Y positions, those are fine. We are going to set the stroke. Do we want to just pull this in? Maybe we'll say here, you can specify the stroke width. Maybe we derive a reasonable stroke width based off of the scale of the thing. That seems pretty reasonable. So here we can say like stroke width is going to be a F32. And here we just say stroke width is equal to as F32 float from int width, what, over like 1,000? So 100, I want 0.1. Yeah, it's literally over 1,000. That's fine. And maybe we'll take in a fill as well. Letting them choose the color seems reasonable. Set attribute fill. Maybe we'll just write color. And then we can say that the fill is color and the stroke is also color. Okay. And then the problem here is that our XML builder, I don't think, supports putting anything except a node inside something, so we have to fix that. So I think it's just here, instead of add node, we need something else that's like add data. Add data. And this will just take in data, and it'll just fucking write it directly. So here, inserting an indent probably makes sense. Inserting the indent, sure. No tagging to do, but we will just write the thing in here into the writer. And the state does not change. Okay. So here now we should be able to say try self svg builder, add data, and we pass in the text. Stroke width wrong, thank you. Okay, and let's like just run that and see if it like made something sane. Oh, we didn't actually use the function, so it won't do anything. So try visualizer draw text at the ROI left and ROI top. And the color, we'll just make it like red, I don't care, and the text is going to be I, which means that we need to like do some sort of zig into text. Buff print alloc print. Yeah, let's just fuck it. Fuck it. This is stupid, but I don't want to think about it, so we're just gonna do it this way. Var is is equal to this. For alloc free is, then we pass in is. Great. Close. Draw text. This has to be try, I guess. Expected tuple or struct argument found usize. So that's here. I have to put that in little squigglies. Okay, let's see what happened. Hey, that did something. I forgot to set the font size. So here, I guess we'll just say font size F32. And font size is going to be this thing divided by 500. I don't know. Fuck it. Font size. This is a num. Like this. Not good. Oh, maybe it's after over 50. Okay. Wait, that's not bad at all. So this is the lower left corner of the font, though. So let's kind of like adjust its position a little bit. So this would be ROI bottom plus QR code LM width over 3. Fuck it. And this should be left plus QR code dot LM width over 3. And I guess technically it should be LM height, even though they're going to be identical. Minus. Hey, that's not bad at all. Look at that. Look at that. That's so sick. Man, that's so fucking cool. Okay, let's iterate a little more than 20 times. Let's iterate 50 times and just see what happens. Okay. So clearly there's some bugs going on here. Can we just zoom in maybe like to 2000%? Right? So it looks like we did okay on the way up. But on the way down, it looks like we made multiple mistakes. Like, we should have shifted over 2. Oh, hold on. Let's look at this thing again. So we assumed that. Oh yeah, okay. So the order is always that we are moving to the left when we're zigzagging. But maybe we had to fuck up our zigzag state here. What did we do? So when we get to this corner, we went 23. I think that we did like our reset was wrong. So here when we hit the edge, we were relative to our old position, which kind of makes sense. So we're looking at like 22. And so from our old position, we need to say move to the left. And I guess because we're just continuing here. Oh, hold on. So here we say our next move is going to be horizontal. So moving our X here. Where are we supposed to go? We're supposed to go here, then here. Boom, 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 boom. Okay. Which means that we need to Oh, okay. So there's something here where I'm assuming that we're always alternating horizontal and vertical. But that's not true here, because here we have to move horizontal 3 times in a row. Okay, well that makes sense because we didn't actually alternate next move vertical here, which is good. Do we expect our next... Wait, so before we hit this problem because we went up into an invalid spot. Which means that our next move vertical state needs to be inverted. We want to say, hey, we're moving horizontal now, and then we want to set our position to be here. And then we want to like return this rectangle. Maybe. I don't fucking know. Okay. We're just going to get crazy here. And we'll see what happens. So here we say our X position is now this. Then we want to say that we are moving. This is just going to be false unconditionally. And the next move vertical is going to be false unconditionally. Yeah. That sounds right to me. So we set our position here and we say, please go horizontal next. And then moving up should be, yep, we're going to be moving down now. But I guess this is actually an inversion. Because moving up is not about if we're vertically moving, it's about if we're moving up or down. Okay, let's try that. Close. A lot closer. I moved 2 over when I should have moved 1. So this times 2 looks like it's incorrect. Okay. So 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Great. And now the only problem is we also have to do that same inversion if we hit the edge of the image, which is fine. That is valid thing. Just has to return if we're in the finder regions, or self.x pause is greater than or equal to self.qrcode.ry.bottom. This is y pause. I guess I don't really like doing these comparisons so like in line, because I feel like there's like I'm going to forget to add like floating point error margins all over the place. So it might be nice to just say, do I know the length of valid region? I feel like technically I'm supposed to. I think I saw something about like versions of the QR code being parsable and then being able to derive the grid size from that. But I'm not doing that because I'm being a stupid dumbass. So I'm just trying to like check myself every time, which might be stupid, but whatever, you know? Okay, whatever. I'm just gonna do this for now, and I'm gonna slap a fix me. Move ROI calculations into function with edge with floating point imprecision handling. But for now, we're just gonna say if our x position is greater than self QR code dot ROI right minus self QR code LM width over 2.0. Maybe use integer positions. Yeah, I've also been considering that. That's also not a bad idea. Or use integer coordinates everywhere. In fact, we're going to need to use integer coordinates everywhere when we try to apply the masking pattern. Do I want to do that now? I think I don't. Even though I know it's necessary. I don't want to. Or x is less than the left edge plus this, or y is greater than the bottom, or y is less than the top. Don't know how to handle horizontal out of bounds. Oh, interesting. So we immediately got not valid at 8888. Can I open this in color paint and see where the edge is? So what did I fuck up? So 8888 is here, which should be totally within bounds. Okay, so x is greater than the right. X is less than the left. I guess we just have to fucking... Ugh. We have to determine which one of these is wrong. So y is greater than the bottom minus the element width. I guess this is technically element height. Not that it matters. Oh, here, I wrote bottom twice. That's probably it. Okay, that's looking better. Oh, hell yeah. 0, 1, 2, 3, 4. Is this case for multi-object loop? What's multi-object loop mean? Is that like a thing that... not a term that's at least Googleable. I don't know what that means, but maybe. Check both squares in one iteration. check both squares. Both squares of what? Because I'm trying to check for, in each iteration, I'm trying to check if I'm in this, or the total. Oh, you're talking about a zig thing. Multi-object for. Let me think. I think no, but I could be wrong. I think probably like what I would naturally want to do is I would want to maybe do more of like a rectangle intersection, like check. So I think the correct thing to do is just check if my ROI overlaps with any of the invalid ROIs or something. Like I think just like a double for loop probably makes more sense, but I could be wrong. Okay, let's try getting crazy and capping, like letting this go a lot farther. So let's try like 150 just to see. Okay, so that's looking good, except it looks like the top edge check is bad, and I think you're also supposed to skip these timing patterns. Actually, I think you're supposed to skip the timing row. Let's see. Yeah, it does look like we're just supposed to skip the timing row, which actually means that the concept of smacking into the edge and then turning is not valid, right? Because here, if we hit the timing row, then we're supposed to skip one. Oh! And if we hit the alignment thing, we're also supposed to skip one. And what the fuck is this? Oh, this is fine. This is still the same thing. Okay. Okay. So it's like, if in timing pattern, skip. If hits these sections, turn around. So I guess you actually need something that's like, this spec is crazy. I mean, I'm sure that there's probably a better way to do this. There's probably like you guys have been saying, like hinting at, probably I should just hard code it. But that's no fun. That's not fun at all. Okay, so we're gonna call this, instead of is valid, we're gonna call this should turn around. And then we can say if, then we have to invert this return. And here we're gonna say if we should turn around, we do this shit. Could you just special case those timing y and x positions when you increment? I think that's what I was gonna end up doing, but I was just gonna call it something else. I was gonna say like, I was gonna make a new thing that's like should skip. And I don't know what I want to put in here, but maybe the rect that we're looking at is fine. Maybe at this point this is probably a good time to switch to index-based iteration instead of fucking floating point, because I think that this is just going to get more and more complex. So let's do that. X pause. So here, how do we want to index this thing? Probably from top left to stay consistent with the floating point, like the ROI order. So I think that we're going to specify our grid, and I think that the top left also matches up with the masking thing here, right? Because they're saying J%3 is 0, and they're considering left edge here. It looks like as 0, not right edge. So let's do, these are going to be U sizes now, and we're going to start ourselves at something. We're going to have to like determine like the grid size. So in our QR code, we're specifying the width and the ROI. So I guess like, maybe in our QR code, we're going to make a function that's like IDX to ROI. That makes sense. And here he's going to return a rectangle. And I guess an optional rectangle because the index might not be within the region of interest. And here we're going to pass in an X and a Y. And I guess we're just going to say X plus elem width, or X plus self dot ROI left times self elem width. Var left is equal to this. I guess const. Right is going to be left plus self elem width. Top is going to be the same thing, but for Y. And bottom is going to be top plus self elem height. And I guess we'll just allow people to say whatever index you want, but if you're out of bounds, get fucked. I guess that's fine. I'm okay with that for now. So for this, we're going to say, oopsies, delete word, put a dot, go to the end and replace the comma. Okay. Oh, these do need to be variables outside because we're using them. So what's fine. Return left equal left. Right equal right. Top equal top. Bottom equal bottom. Okay. And then let's get another thing that's like pub function width elems width num horiz elems, I guess, is a word we could use for this. It's going to return usize. And here he's just going to return self ROI width divided by self LM width, and then he's going to round this guy. Float or int from float. Okay. And we're going to do the same thing vertical. So it's going to be height over LM height. Okay. Sure. So now when we construct this guy, we can say our X position is going to be QR code num horizontal elements. Our Y position is going to be the QR code num vertical elements. And then all of this math related to LM width, I guess, just goes away. So this is going to be X pos plus equals 1. Vert movement is equal to 1. Y pos plus equals vert movement, great. X pos minus equals 1. Then for our rectangle, we need to say self QR code IDX to ROI, and we just pass in X pos and Y pos. Great. And should turn around. Well, I'm just going to leave this the same for now, but we'll fix it in a second. This is going to be minus equal 1. And new rect is just going to be self QR code IDX to ROI. Self X pos, self Y pos. Okay. Hey, do you live in Canada? Yeah. Why are you asking? Little Canadian boy. Okay, let's see if that still works. 380. This should be... Oh, fuck. Because these are U sizes, then we can't do, like, negative math. So here we will just do if moving 1, Y pos minus equals 1, else it's plus equals 1. Okay, let's see if that works. Not quite. 495. So that's here. Right, so we need to float cast this, I guess. And not float cast, float from int. And this needs to be as f32. And the same thing here. As f32 float from int x y. And oops, this should be elm height. Off topic, but would love to hear thoughts on U of T versus U Waterloo on computer science. I'm not going to pretend that I have a reasonable opinion on that. Because I didn't really evaluate either of those when I went to university. And when I went to university was a long time ago. I live in Vancouver, and so I was just like, dude, I was so fucking dumb. I just like applied to only the one university next to where I lived, and then was like, I will go here now, and then just like happened to get in. It was so fucking borderline. So I don't really have much opinion. I guess like hiring, maybe do I run into that? I've never really like been first stage hiring either. So by the time I've ever looked at anybody's resume, the university is almost irrelevant. By the time I'm looking at the resume, I'm only looking at like previous work experience and side projects. So unfortunately don't have a good opinion. I know that like I've heard of Waterloo and computer science in general, but I don't think that I can't really give an opinion on if like I personally would like almost wouldn't care at all, but I'm also not the person that's sorting resumes, so it's like can't answer. Vancouver's so pretty, love that place. Dude, it's so pretty. It costs a fair amount, but like damn, it's like it's so sick to be able to like go to Whistler and go fucking skiing and then go to the beach. Not that I do either of those things regularly, but the fact that they're there is sick. I go to the uni in the city you love. Isn't U of T and University of Waterloo kind of like the same though? Aren't they like pretty close by to each other? I don't actually know. And I was about to Google Maps, but then when I open Google Maps, it'll like give my location away, so I can't do that. That's bad. Okay, so it ended up starting me at 2220, and I got immediately invalid here. So I drew off the corner on iteration 0, so probably I just have an off by 1 on my initial Y position. Next move vertical. Or maybe it was, I can't remember what this looked like before. Maybe it was like this, -1 here. It does kind of seem like based off of the one thing that's being drawn, I should just be Y pause -1 here. Oops. XML parsing error. Wow. Oh, probably because I refreshed before it was done. Okay. So here I went 0, 1, and then immediately 2, 3, which seems bad here. This is supposed to go up. So moving up should be true. Next move vertical should be true. Let's limit ourselves again to a few iterations. Switching integer is surprisingly easy so far. I mean, it doesn't work yet, so let's not get ahead of ourselves. So he's saying immediately position 2219 is not valid. And then returns 1920. So it seems like our first position should be valid, which kind of makes me think that like these guys are off by 1 in some way. Well, oh, okay, so maybe I should just like actually fucking think. So here, if next new move vertical is true, which it is on the first iteration, we increment our x by 1 and subtract y by 1. So it kind of feels like this should be the initial state, because then we'll start down here and then immediately jump up to this guy. But it didn't do that. Because he immediately said 2120 is not valid. And what is the grid size of this guy? Can we figure that out? I guess we can print it. because we know. We know here. We can say std debug print. Width is this and height is this. And we have QR code num horiz elims and a QR code num vert elims. I guess there's a chance that the math is bugged here though, and so we should probably also count manually. So it thinks it's 21 by 21. And can we just like double check that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it thinks it's 21 by 21, which is correct. Wait, unless I counted 0. 1, 2, okay, we're starting at 1. Gotta remember that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21. But I started at 1, which means that it's 20 wide, which means I'm off by 1 on my width and height. Which is surprising to me. I have the ROI width divided by the element width. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So the maximum index would be 20. Which means that the number of elements is 21. Okay, so that's correct. And so here, I want to say that this should be -2 and -1, because the number of elements is 1 greater than the maximum index. And so the number of elements would put me here, but I want to start here. So maybe like that. Let's try that. Oh, there we go. Fixed it. Fixed it. Indexing is fucking hard. Okay, and let's go back to main and drop this back up to like 150. Refresh. And now I think we're back in the same state we were before, but it's where it's not great, which is good. And then I also wanted to fix the part where we're checking our edge bounds. We were doing this. This should turn around is based off of floating point rectangle, and now it shouldn't be. So let's switch this to X usize, Y usize. I guess we could even do this based off of our current position. Let's take in usize and Y usize. I think that is clearer. Okay. So now we don't have to worry about this stuff anymore. And I think probably what makes more sense is maybe we have like const finders. That's fine. X is in finder region is if we are now this is just less than finder num elements, or X is greater than width minus finder num elements. Okay. Which means that here I'm going to store our width and height. Just to make things simpler. So const width is equal to this. And const height is equal to this. And then we use width -2 and height here, and then store width is equal to width, and height is equal to height. Sure. I don't know if this is like where I want everything to go, but I just want to start somewhere. And then here, y is less than the... This looks like we're doing finder num elements. Then this guy, it looks like in finder region, we have to give this the same treatment, but we just have to reverse all of the x's and y's. So we're just going to copy paste this whole thing and say y, x, and this is height now, but that should be the same. Boom. And then here, this is supposed to be finder num elements. Oh, wait. This is just greater than or equal to width now. And then this is x is less than 0, which is like unrepresentable. We can't represent x is less than 0 now. Which is kind of confusing, partially. because it means that this like x pause minus equals 1 and y pause minus equals 1 actually can't be done, which is going to be annoying. So I'm just going to change these to I64s, I32s, because I don't want to fucking deal with it, you know? You know? Because then we can like go off the edge and then we can just say here, or x is less than 0. Or y is less than 0. And certainly there's going to be a bunch of issues with this now, but we'll live. Int cast. Int cast. And maybe there'll be some crashes, maybe there won't be. Who knows? Please tell me that we're good. Should turn around now takes in arguments, right? So should turn around takes in self.x and self.y. Is it x pause? Yep. Which I'm not sure I like that name anymore, but it's fine. And should turn around will now take in I32s. Okay. And we're chilling. That looks okay. Now let's go back to main and we'll add in like maybe 100 iterations. See if it still looks okay. Are we back to where we want it to be? That looks decent, except we're going too high up because this is supposed to be +2 on all of these. Because there's 2 extra rows around the finder. No? Hello? Why didn't that do anything? X is less than finder num elements +2. Y is greater than finder num elements -2. X is less than... So this is the top right one. Why are we going right up to the edge? So this is going to be y in finder region. If y is less than... Oh, I forgot one of the +2s. That would do it. There we go. Okay. Okay. And now we can finally start adding that function should skip. And this is going to take in a x and a y, return a bool. Okay. And here we're going to look for the timing patterns. Which means probably this constant is just going to be like timer pattern offset. And I think that this is just happens to be the same here. This is 0, 1, 2, 3, 4, 5, 6. Not the same. And here we can then take in wherever the fuck we were. This guy, he'll just say, if x is equal to finder num, nope, timing pattern offset, and, well, there's no and to think about here. If it's just if x is equal to this, or y is equal to that. So we can just return that directly. Return x is equal to the timer finder offset, or y is equal to the timer pattern offset. Great. We don't need to take in self here, which is interesting. And then basically here, while we are moving vertically, we'll just do while should skip self.x pause, self.y pause. Oh, wait, no. No. This needs to be a do while loop, but there is no do while loop. Because we need to do this once unconditionally. Right. So you almost want to do like function try increment position or something. I don't know. I don't fucking care. So this will be this. Right? Yeah. And then we'll say self inc position, and then we'll just say while should skip self x pause self y pause. We self inc position again. Boom. And I guess technically this could be an if statement, but I think that later it being a while loop might make more sense. So let's just try that for now. And then let's go to main and crank this up to like 150. Okay, so this is not good. This is not good at all. So here it correctly identified this guy, but then he turned around instead. What I want, I just want him to keep going in the same direction. So should skip inc position. He doesn't change anything but x and y position. So shouldn't he should just keep going. He should just keep going up. That was what I intended. Okay, let's log should skip at least. So std debug print skipping. And he needs a little second argument for the parameters that don't exist. Okay. So he skipped. That's not helpful. Okay, can we also limit ourselves to maybe going to 124? If we do that, then the last thing that we see will be the last thing where it wasn't right. Oops, 125. Okay, so now we get this guy, and he's going to say, hey, I skipped, and then I was immediately not valid, and so I jumped backwards, which is interesting. So this not valid check is just fucking wrong. Again. It's, should turn around. So here it's probably something like we chopped ourselves off here and here. So X in finder region, Y in finder region. Maybe we just breakpoint stood debug print. We'll just log both, and we'll just know that it's X in finder region and Y in finder region. Because I'm going to immediately take this print out, so it doesn't fucking matter. So here you got both of those are in the finder region, which is wrong. X should not be in the finder region here. So we can look at this. So we have X is less than finder num elements plus 2, okay? Or it's greater than finder num elements minus 2. And Y is less than this. Okay, let's print out. This feels wrong. Stood debug print X is going to be a number. And then we're going to have width is going to be a number. Num elements it's just a constant, so we don't have to worry about that. Let's just log these. X and self width. So X 9 width 21. Oh, sorry, X 13 width 21. This is the problematic one. X 13 W 21. So this is 13 is greater than 21 minus 7 minus 2. 21 minus 7 is 14 minus 2. So I guess this is, in fact, true. So what the fuck is going on there? Oh, but there is one amount of padding here. Oh! There's no format info here. No format info here. So this should be a -1. And should be a greater than or equal to. And I don't know if Y in Finder region has the same problem. Format info, format info. No format info here. So it looks like it probably does. I'm going to apply the same thing here. I'm not positive, but get fucked, I guess. Okay, so it did the same thing here. 13 with true true. Am I fucking high? 21 minus 7. Oh, this is just... Maybe I shouldn't have greater than or equal that. Closer. Ink position is moving twice to the right when he shouldn't be. He should just keep going up here. So maybe this is actually more of a while should skip goes here. Yeah, like here. It does kind of feel like this more. Yeah. And it's almost like we should go back to this being setting some adjustment. So we can just say if self moving up, y adjustment equals -1. And then while we should skip self y pause plus equals y adjustment, and then while we should skip, we keep going. Oh, I hate this. I'm sure that there's like a more elegant way to do all of this. But you know, what you gonna do? And what I'm going to do is I'm gonna fix it off stream because I don't want to deal with fucking code prettiness right now. This is an I32. Okay, please. Okay, that looks good. 124 going here is a good sign. Great sign. Let's try looking at 160 or something. Let's just keep going and see what happens. Ooh, core dump. That's kind of fun. IDX to ROI. So this probably hit like Y going off the top of the screen. That would be my guess, is that Y pause is almost certainly -1 here. We could even check by just running GDB. Frame 6. P self dot Y pause. First time here, but this is cool as hell. Thanks, man. Yeah, we're just hitting a -1 case. So this is at line, what, 404? In QR. So it's just this. Okay. Which kind of makes sense. This should just go down here. Because that rect isn't used anywhere. So let's try it again. Okay, and let's see where he went. So that looks really promising. This 158 is down here. We skip this twice, right? We have like 146, 147, 148, 149. Does this zigzag look right? 1, 3, 4, 5, 6, 7. Solid. Okay, let's try going a little farther. Let's try like 200. Okay, and let's try... Oh, do not know how to handle horizontal out of bounds. Oh, perfect. Okay, so we are hitting that we like are in this like out of bounds section here. And then giving up. Which is exactly what I expected to happen. And based off of some picture on Wikipedia, this one, we actually have some indication that we could skip that because it's out of bounds. It's out of bounds. Out of bounds. Okay, so the next thing that we want to do is we want to like apply the mask. We didn't ever actually apply it. And then once we've applied the mask, then we can actually start looking at the data that's in there. But we are at about a perfect 2-hour mark. We're at 1:55. So I don't think that we're going to get we're not going to like get much further than this today if we are stopping at 2 hours. So I think I'm going to call it there for now. Good progress. Once again, this is like, again, like I keep thinking that we're going to get there, and then we just keep not getting there. But we've made good progress, right? So what did we do today? We managed to like look at this format info stuff here, extract which version of the mask we're going to be using, and then we set up this like grid iterator. This was much harder than I thought it was going to be. But he kind of goes like zigzaggy like this, up, 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 and then he hits the edge and he goes right, and then he zigzags back down, and then he does the same thing but skips the timing info. So looking pretty good. Yeah, happy with that. So cool. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Right now it's 4 o'clock, so anytime between 2 hours ago and now. So if you like what you saw, you can swing back by whenever. If you are new here, there's a YouTube channel that's linked to the Twitch description where we have VODs of all of our previous projects. So playlists are set up project by project, and then on GitHub as well, projects are there. Examples of things that you might see in there, like operating system, neural network, terminal emulator, Git GUI, diff algorithms, virtual file systems. I'm sure there's more. Kind of whatever the fuck we feel like doing. Yeah. So thanks for watching, guys, and hopefully catch you on the next one. Bye.